म्यूट कर दीजिए, पीछे बैकग्राउंड से बहुत नॉइस आ रही है। तो हम कौन सा पेपर कर रहे थे? वी वर डूइंग फरवरी मार्च 2020 पेपर 5-2 and we have ended question number 1. Oh, sorry, we have ended question number 2. And we are going to start with question number 1 today. Okay. So have a look. Brass is an alloy of copper and zinc. Typical copper concentrations vary from 50 to 80% depending upon the properties needed in the alloy. Okay. There may be a small amount of other metals present as well. Okay. So they have kept the composition of a copper from 50% to 85%. Okay. And they said that there must be some other, metals that might be present. Okay. A student found a method to find the percentage of copper in a sample of brass. Okay. So what is the experiment that we have to have method, and by that method we are going to determine the percentage of copper in a sample of brass. Okay. Reacted with the excess concentrated nitric acid, both the copper and zinc and any other metal present are oxidized into aqueous ions by nitric acid. Okay. The amount of copper ions present can be determined by the titration technique. Okay. So it means whatever the elements, the metals over there in the brass, all are oxidized, and out of those, what we do, we by titration. Okay, so here we have our steps how we did it. Step 1, use a weighing board to accurately weigh by a difference approximately 2 grams of brass powder and place the brass powder into a small glass beaker. Okay. Then in a fume cupboard, add approximately 20 centimeter cube of nitric acid to the brass in the beaker. Allow the brass to completely react to form solution A. The equation for the reaction is shown. Okay, why use the fuming cupboard? See, there is a which can cause breathing problems. So that's why we use a fuming cupboard where this gas can be easily escape to the atmosphere. Okay. So step 1 and step 2 is clear to everyone. If anybody have any doubt, kindly ask. Okay. We have got the equation. Dilute all of solution A to form exactly 250 centimeter cube of solution B. Okay. So if you see, solution A is almost 20 centimeter cube, right? And then what we did, if we are preparing a solution, it clearly means that this hole must be 250 centimeter cube, and it's a solution B. And in this solution B, we have that is around 20 centimeter cube of A and in it. Is this understandable? Yes. Now what they are saying, place 25 centimeter cube. Okay, we have this solution A into this flask. Place 25 centimeter cubes of solution B into a conical flask. Okay, so from this solution, 25 centimeter cube is put into a flask from the volumetric flask. Okay. Use a dropping pipette to add aqueous sodium carbonate to a solution B in the conical flask until there is no more acid present. Okay, so if we have added the sodium carbonate, they start reacting, bubbles can be observed. So when the bubble stop, centimeter cube of potassium iodide, aluminum cube, sodium thiosulfate solution. Yes.
आपकी आवाज बहुत कट रही थी.
Okay. So can I repeat step 6?
Step 5B.
Okay. So what we do in the step 4, we transfer 25 centimeter cube of solution B from this volumetric flask to a conical flask and just 25 centimeter cube. Okay.
Right.
Now,
Sir, we still can't hear you.
after that, we put sodium carbonate to this conical flask to make sure that all the acid must be reacted. Yes, Riha? Okay, tell me. Am I audible now?
Yes.
Okay. So, in this step 5, we have added some sodium carbonate in it. And why we are adding it, they have tell us to the purpose that in solution B, so there is no more acid present in it. So if there is any acid in it, if we add some sodium carbonate, it reacts with the sodium carbonate, effervescence of carbon dioxide will be evolved, and all the acid is consumed by adding sodium carbonate. Step 5. Is this clear?
Yes, sir.
Yes.
And okay, that's good. Now, Step 7. Fill a burette with 0.1 mole per dm cube sodium thiosulfate. No, sorry. Step 6. Add approximately 20 centimeter cube of aqueous potassium iodide to the conical flask. A white precipitate forms as well as brown solution of aqueous iodine. Okay. So we are getting the two things. When we have added afterwards sodium potassium iodide in this, so we are observing a white precipitates and brown solution of aqueous iodine. Okay. Then in step 6, we would fill up burette with 0.1 mole per dm cube sodium thiosulfate solution. So it is ready for the titration in step 8. Okay, in step 8, carry out titration for the aqueous iodine produced in conical flask against the 0.1 mole per dm cube of sodium thiosulfate. Okay. Now, these are the 8 steps of the experiment that are performed. Now, let's look at part 1. Outline how students should accurately weigh by difference in step 1 in order that the exact mass of brass transferred into a small glass beaker is known. Include a result table with appropriate headings ready for the student to fill in. Okay, so let's come to step 1 again. What they are saying? Use a weighing board to accurately weigh by difference. Okay, now am I audible?
Yes, sir.
Yes. Okay. So what they are asking to outline the steps. How would you measure or weigh by difference? How would you measure weigh? See this statement. How should accurately weigh by difference in step 1 in order that the exact mass of brass transferred into the small glass beaker is known? First, you have to outline this and then you have to include a result table. Okay. So, anybody can suggest an answer how we would do this? You have to weigh accurately and you have to weigh by difference in step 1. And
Sir,
you
shall I
must
just
know the sorry. Can
first
you
we're
repeat?
gonna weigh the mass of the boat and the brass, and then after, then minus the difference.
Yeah, good. So for that, if you have to weight by difference, first thing you have to know what exact mass could be is exactly transferred into the container, into the beaker. So what we will do? First way, good Soliha. boat and
brass before.
and brass powder together. Okay. Then transfer brass powder to the beaker. Now reweigh the empty boat again. So we would exactly know how much mass of brass is transferred to a conical, to a flask, to a beaker, sorry, and how, and that's what it says, accurately weigh by difference. So how could we do that? Now in the next part, what they are asking as well, include a result tables. Okay, so the result table would be like this. Mass of boat plus brass. So over here slash gram. Then second, mass of boat after transferring, the unit must be gram. And third, mass of brass transferred slash grams. So it would be like this. You have to make the table as well. Yes, is this clear to everyone?
Yes, sir.
Okay. Suggest why it is necessary to do step 2 in a fume cupboard. Yes.
Because toxic gases are released, sir. NO2 is released.
Yes, NO2 is released over here. That's why I have told you. See, fume covered is used due to this NO2. And NO2 is a toxic gas or a poisonous gas. Toxic gas is being released. Now, next part. Outline how the student should carry out step 3 Include the name and capacity of suitable piece of apparatus in which solution B should be prepared. So see, that's what I have shown you the glimpse. So what we do? We are using, volumetric flask, and we are transferring the solution A. So you have to outline the method, outline how we would prepare. So first step, transfer solution A into a volumetric flask of 250 centimeter cube, then transfer the washings of A as well. Obviously, if you don't transfer the first one or two washings, so there must be a dilution. Okay, so in whatever it was present in the beaker, right? So from the beaker we have transferred into the volumetric flask, then we put some distilled water in that empty beaker with the traces of our A. We rinse it and then transfer that in volumetric flask as well to make sure that all of the solution A must be transferred. Okay, now after this, fill the volumetric flask up to the mark. There is a mark on the neck of the flask with distilled water. Okay, so what happened? See, the volumetric flask is like this. Here there is a mark on the neck. We have a 250 centimeter cube volume. So first we transferred A, then we transferred some of its washing, and then we filled the whole thing till the mark with the distilled water to make up the whole solution. Is it clear to everyone?
Yes, sir.
Okay. Next, name the apparatus needed to transfer solution B into a conical flask in step 4. So C. Look over here. From here, the titration part is starting, and from this, as I've told you, we have transferring 25 centimeter cube of B into flask. Yes, so most of you guys, I hope, performed titration previous year. So can anybody tell me which apparatus we use to transfer?
Pipette, 25 C into pipette.
We use pipette. We always use pipette to transfer 25 centimeter cube of our reagent into a conical flask, and then we add the indicator, and then we add the other reagent from the Buret. So here we go, pipette. State how the student would know there was no more acid present in the mixture in step 5. Yes, I have told you at that moment. Read this. I have told you at that moment. How could you observe?
No
When
more
the bubbles
effervescence
stop.
of CO2.
Sorry, one by one,
No
please.
more effervescence. No more effervescence.
Yes, Ahmed, what you were saying?
I was saying the same.
Okay, so no more effervescence, or the effervescence forming stopped. No more effervescence. Okay, next part. If anybody have any confusion till party, do ask. The student is given 200 centimeter cube of 0.1 sodium outline how the 7. So it is ready for the follow any reading are taken. Okay. First of all, 2 marks, so you need to make 2 points over here. So that is the way whenever we are going to use any reagent in the Buret, we first rinse the Buret with the same reagent. So you can easily write this 1 point, rinse the Buret with sodium thiosulfate. And while rinsing, what we do, this is the Buret. Here we have a tap. So what we do, we fill some amount over here, we just shake it and remove it from over there by, tilting it. So when you are rinsing it, this tap must be opened, so it could be rinsed from this side of the Buret. So you can include this that remove some Na2S2O3 sodium thiosulfate during rinsing from the tap as well. Is this clear to everyone? Yes. Now G part. Okay. If anybody have any doubt over here, till here, do ask. The titration table the student used is shown. Complete the table and calculate the mean titer to be used in calculating the percentage of copper in brass. Okay. So here the titer would be 20.50. Can anybody tell me the difference? It is 19 point, if I'm not wrong. 19.35. Can anybody check and tell me?
19.65.
Which one is 19.65? This one, first
Number
one?
one. Yeah.
19.65. Okay. 19.90. And the third one? Yes.
19.75.
19.75. Okay. Now I have to find the mean titer. So there is one important thing which you have to be note over here, that every time whenever you are noting down the titration readings, these titration readings must be in 2 decimal places. See, instead of writing just 0, it is written 0.00, right? So your every answer must be in a 2 decimal places. Okay. So if I go for the mean titer, first I have to figure out the best results. And if you see out of these, the closest one are these two, right? So I can consider these two as my best result, and then I take the average out of these two. So 19.65 plus 19.75 divided by 2 gives you 19.70. Is this understandable? Yes. If anybody have any doubt or any question, kindly ask.
सर लास्ट पार्ट बताइएगा मीन टाइट्रेशन वाला.
To make the mean titration, mean titer, we always need two best results. Okay, that is what we tell the students while they are doing practicals. You need only two results with a difference of 0.1 only. Okay, that can be used for further calculation. So if you see, it's 19.65 and it is 19.75. So between these two, there is a difference of only 0.1.
Yes, sir.
So that's why I have chosen these two and ignore all rest of them.
So, sir, in every case, we have to choose two.
Yes, you have to choose two, and those two that you are choosing must have a difference of 0.1, not bigger than that.
Okay. And can it be smaller than that?
Very rarely, but very rarely it can be smaller than that.
Oh,
Okay, and there is one more thing about this. Have a look over here. For example, let's assume in your first iteration you got 19.65. Okay, it's for everyone. Be attentive.
yes, sir.
In the second iteration, you are getting 19.85, for example. And in the third titer is now 19.75. Now, which one you would choose?
Sir, can you please repeat?
I am saying, let's assume, in this case, I have a two readings with a 0.1 difference and I have calculated the mean titer, okay?
Yes, sir.
But in another experiment, the titer that you have actually when you titrated in the first experiment, the titer, the volume that uses, for example, 20.10, in the second it is 20.20, and in the third it is 20.30 in the second, and when you did perform the third time you got 20.20. Now if you see these three titers, so to get the mean, which values you can use, or which values you have to use?
Sir, तीनों use कर लेंगे?
Now,
Lowest value.
yes, in this case, very good. We use all three values, because if I compare these two, they have a 0.1 difference, but these two also have a 0.1 difference, right?
Right.
So now because these values have a difference of 0.1, so I must use all the three values to take the mean value to calculate the titer. But in this case, if you see, we have only two values with a 0.1 difference, so we only choose those two.
Sir,
Is
if
it
we
clear to everyone?
yes, sir. Sir, if we had the first titer as 19.55 instead of 19.6.
Okay. Okay, let me write with that red. You are saying instead we get this. Okay.
Yes, sir.
Okay. Then
Then how would we calculate the mean titer?
I have to go for the third titration or fourth titration as well, because there is a no two values have a difference of 0.1.
Okay.
Okay. because there is
Yes.
so if there is a difference of 0.1, so for instance, here I got 19.65, my first iter, and my second iter would be 19.55 or 19.75, so I don't need to do the third. I have to just choose these two and do the rest of the calculation.
Okay, sir.
I hope it's clear to everyone, all the conditions.
Yes, sir.
So the mean titer is 19.70. Let's proceed. The burette used by the student has a graduation of 0.1 centimeter cube. Okay. Determine the percentage error in the titer measured in titration number 2. Show your working. Yes, in titration number 2, here it is. Okay, let me write. Final burette reading was 19.90. Initial burette reading was 0.00, and the titer is 19.90. Here you go. Yes, can anybody tell me how we would, uh,
Sir,
find that?
0.1 divided by 19.9 into 100.
Wrong.
0.05.
Why you are 0.1? By the way, you are right. But you have to show your work. If you will do 0.10
सर आपकी आवाज
divided
कट गई,
by,
आप क्या कह रहे थे?
I am saying that examiner is said show your working. So if you do 0.10 divided by 19.90 times 100, it will give you the correct answer, but it is marked as wrong because your working is incomplete and examiner mentioned to show your working. So see, if the graduation is 0.1, so what would be the error? The error would be plus minus 0.05, right? That is the error basically when you noted this initial reading, you have this error 0.005. When you have noted this reading, you have an error of 0.05 again, right? So you have to show the error and then make it times 2 to show, because we have used, or we have taken the reading from the burette twice, and my error is 0.05 and I'm doing it twice, so that's why I'm multiplying it twice, divided by 19.90, multiply by 100. Yes, can anybody tell me the answer?
0.50.
0.50. Okay.
Sir, how do we know the error
Now,
0.05?
okay. See, it's a burette, right, Alisa? Here it is 0. It's then it's 1. Okay. So if the liquid is filled over here like this, okay, let me do this. So what would you read from here?
0.5. 1.5.
Yes. What would be the reading over here? 0.5. 0.5. Why
Yes, sir.
1.5? What could be the chance of error over here? यहाँ पे क्या error हो सकता है? What would be the chance? Because the smaller unit is 0.4 and the bigger unit is 0.6. So it means the value that I am noting over here, 0.5, have only an error of 0.05 because that is the smallest unit in this Buret is 0.1, right? तो हमेशा एरर जो होता है वो आपका जो लीस्ट काउंट होता है या जो स्मॉलेस्ट एरर होता है उसको हम डिवाइड बाय 2 करते हैं तो यू विल गेट द एरर. Is it clear now?
Yes, sir.
Okay, if anybody else have any doubt, kindly ask. Okay, next part. Other than a change in apparatus, suggest one change to the experiment which would lead to reduction in the percentage error in the measured titer. Yes. You are not allowed to change the apparatus. You have to suggest one change to the experiment which would lead to reduction in the percentage error in the yes. What I was okay, just tell me or just think, how can I reduce this percentage error? Can I reduce this percentage error if this volume is increased?
Yes.
So this volume is actually
Your voice is lagging.
सर आपकी वॉइस लैग कर रही है तो
Yes, am I audible now?
Yes.
Hello, am I audible now?
Yes, sir.
Yes, sir.
Okay. So what I was saying that if this volume is increased, then obviously the percentage error would be reduced, right? Yes.
Yes, sir.
Yes, sir.
So, and this volume of sodium thiosulfate is actually reacting with the mass of the brass that was dissolved initially, right? That we did over here in the step 1. So if I increase the mass of a brass that I used, then we need a larger, then we need a larger volume of brass, of this titer, and hence when there is a larger volume of our titer, so the percentage error would be reduced. So mass of brass is increase the mass of the brass. Is it clear? Okay.
So why do you increase the mass of brass?
Okay, see. Are you agree with this, Mariam, that if this volume is increased, then the percentage error would be reduced?
Yes.
Okay. So if you read these steps, we have added 2 grams of brass, right? And then we added 20 centimeter cube of nitric acid, and that which makes the solution A, and that solution A is diluted to 250 centimeter cube to make the solution B, and this would be transferred in 25 centimeter cube of flask. See over here till step 4. Then what we do, see over here, we fill the burette with sodium thiosulfate, and that thiosulfate would be added into this conical flask for the reaction to occur, right? Yes, Mariam?
Yes, sir.
And the volume of this thiosulfate used is 19.90, right? So if instead of 2 gram, I use 4 gram or 5 gram of brass, so there must be more content or more number of moles in this flask. And then when I titrate it, now instead of 19.90, might be, it would be, I don't know, 39.50 or any other volume that would be used, right? Yes, did you understand?
Yes, sir.
So that's why we increase the mass of the brass, so that there is a more content in the beaker, in the flask, and now we have to use the more volume of this is consumed, so our error must be decreased in this way. Okay. Okay, this is the calculation. Okay, so I'm ending the session over here. We are left with the calculation, and it's this. Okay, so first you guys will try to do it. Otherwise, on Thursday class before the next paper, I will discuss this, and then we will move to the next paper. Okay. Okay. Take care, everyone. Allah Hafiz.
Officer.